all. Now we are going to discuss about the second class of organic compounds called as ethers. Ethers are the complex organic compounds which are having the functional group ROR. These R are alkyl groups and the O is the ethereal oxygen. So basing on these alkyl groups, ethers are classified into two types. One is symmetrical ethers and the second one is unsymmetrical ethers. Symmetrical ethers means here the two alkyl groups are similar. They may be aliphatic or aromatic. For example, I am going to take dimethyl ether CH3OCH3, diethyl ether C2H5OCH3, diphenyl ether C6H5O C6H5. So coming to the unsymmetrical, the two alkyl groups are different. So if you take these unsymmetrical ethers, I can take methyl ethyl ether, propyl methyl ether, butyl methyl ether, like that. So in this case of unsymmetrical ethers, we may take one alkyl group and the second one aryl group also. For example, I can take phenyl methyl ether, which is commonly called as anisole, and phenyl ethyl ether, commonly called as phenetol. So these anisole and phenetol are aromatic ethers which are widely used as solvents. So basically these ethers may be used as thermometric liquids and dry solvents, especially in the Grignard reagent applications for the preparation of various organic compounds in the organic chemistry. Now if you see the nomenclature, these ethers are named under a specific system of nomenclature called as IUPAC system, which is called as International Union of Pure and Applied Chemistry. And according to this system of nomenclature, these are named as alkoxyalkanes. Alkoxyalkanes. For example, I can write this dimethyl ether as methoxymethane, this diethyl ether as ethoxyethane, this diphenyl as diphenoxy ether, and if you come to this, it is methoxyethane and methoxypropane, methoxybutane, and this is methoxybenzene. Methoxybenzene is commonly called as anisole and ethoxybenzene is commonly called as phenetol. If you see the structure of this here, the oxygen atom is undergoing sp3 hybridization. It forms two sigma sp3 hybrid orbitals with sigma bonds with two carbon atoms of alkyl groups, and the remaining two is having a two lone pair of electrons. So we can say it is a angular structure just like water. Basing on this, we can proceed for the methods of preparations of ether in the next class.